So in problem number 1, it says which is the domain of this function. So for these problems, there's going to be no calculator. You need to know how the parent graph is supposed to look. So as you remember, the function f of x equals 6 to the x power. Do you remember how that looks? Is it an increasing function or decreasing function? We always read it from left to right. Is it what? Or you don't remember? Okay, well just...
Decrease.
Is it decreasing? Okay, let's see. It's supposed to go at x is equals to -1. Tell me what happens at x equals to -1. 6 to the -1. Is that more than 1 or less than 1? It's less than 1 because it's 1 over 6. Okay, so it would be 1/6. At x is equal to 0. 1. That would be 1. At x is equals to 1? 6. So you tell me, is that an increasing function or decreasing function? It's an increasing function. Okay, so that's supposed to be the graph of the 6 to the x power. What about if you have the negative on the x? Over the y. So you reflect that over the y, so you're going to have it coming like this. Like that. So it's going to be, it's not going to be an increasing function anymore. Now it's going to be a decreasing function. But you still need, to include all the values from negative infinity to positive infinity. So therefore, the solution for this should be what? Should be A. Yeah, so the answer is A. Okay, so A.
Why not? Why doesn't it stop at 2?
It doesn't stop because at x is equal to 0, 6 to the 0 power, it's 1. Anything to the 0 power is 1. So you have an asymptote that is y is equal to 0, which is the x-axis. That's the asymptote. So that would be for the range.
Oh.
On the range, you're going to have from 0 to positive infinity. Good point. Okay. Now for now, and it's parentheses on the 0, not a bracket. Okay. So for number 2, which function is a transformation of f of x equals to 3 to the x power when it's 2 units to the right? That would be g. That is right. Yes. See right here, that's negative x minus 2. Then that is a transformation to the right. If it was to be to the left, then it would be f. What about h? It's a vertical stretch by a factor of 2. And what about j? What is that supposed to be? 2 units up. So it's translated up 2 units. Okay. So for this is letter G. How about number 3? In the continuous compound interest formula, A equals to PERT, which variable determines the amount of time it takes for the investment to double? So which of this is going to be the one that doubles? Too many letters right there.
Yeah.
So if you want to double it, the time. That is right. So you're going to have the time, which in this case is letter D, which is pretty much what we did right now. We said in 5 years with that double. So then it's mainly the time, which is the D. Okay, so sometimes when they give you an amount and they want to know what's going to be the percent, you can also change that. But the thing is that T would be the one that helps you to determine the amount of time that it takes. Amount of time that it takes, amount of time, it says here. Just the T. Okay. For number 4, which of the following correctly describes the end behavior of f of x as x approaches infinitive? It would be J. In J, that approaches infinitive. Okay, so at x approaches to infinitive, then the y is positive infinitive. So that would be J. Next, how about number 5? When you evaluate that log, what would be the answer for something like that? -3 is right, because the question here is log base 4 of 1/64 equals to what? Well, if you rewrite that logarithmic into exponential, the exponential form would be what? 4 raised to the x equals 1/64.
Which would be 4x equal to
1 over
4 to the
third power, and then you bring that to the top, and that would be, let me just continue here. So it would be 4 raised to the x power equals 4 raised to the -3, because you bring it to the top. And therefore the bases are the same, so the exponents are equal. So then it's going to be -3. So that would be A. Okay, so now let me give you a couple of minutes to work in number 6. See if you can do that number 6. X minus 2 and then plus 3x. All of that is over the same denominator, which is x. Then you combine the like terms. That's going to be 4x minus 2 over x. This is greater than or equal to 0. Then when you create your number line, your values, okay, the first one, this would be x equal to 0. So at x is equal to 0, that's 1. The second one is 4x minus 2 equal to 0. So 4x equals 2 when you move the -2 to the right, divided by 4, so that would be 1/2. Then you put that 1/2, so it's 1/2 and 0. Then you test the areas, like for example, you can try -1,000, 1/4 in the middle, and 1,000. Then you're gonna put that here in this one, the simplified one. So when you put -1,000 times 4 is -4,000, so that's negative. So on the top is going to be negative, divided by, so negative, divided by, in the bottom is going to be negative, negative divided by negative, so that's going to produce a positive. And then at 1/4, well, what is 4 times 1/4? That is 1 minus 2, well, that would be -1. So that would be -1. So it's negative, divided by 1/4, that is positive. So negative divided by positive is negative. And then the 1,000 times 4, that would be positive, divided by positive, and it's going to produce a positive. And what do we want here? We want is greater than, so it's positive interval. So it would be this one, and it would be this one. So from -infinitive to 0 with parentheses, because at 0 you cannot have a 0 in the denominator, so it's with the parentheses. And then or from 1/2 with a bracket, that one you can use it all the way to positive infinitive. So that was B. Okay. Now number 7. Let's go ahead and work on number 7. Let me give you a couple of minutes to work on number 7. How many students are we supposed to have? What did you get? Anybody has an answer?
Don't you just
PERT. This is exponentially. That is right. So for that, we're supposed to have, let me see, let me move it over here, make it a little bigger. So the formula should be the amount, the population, the initial amount of students is 241, and then is E raised to the rate, and the rate is in decimal would be 0.17, and then how many years is from 2009 to 2021? That would be 12 years. So when you put that into the calculator, that would give you how many students? 200, and since these are people, it's to the whole number. 296. Is it a point something higher than, yes, it's 0.5, right? So it's 296. And the next problem. So this is compounded continuously. Are we going to use the PERT also for this one? Yes, right? It says Jasmine invests $1,500 in an account that earns an interest rate of 4% compounded continuously.
The first one, yes. And the second one.
That's right. The second one, that is right. Will she have enough money in 4 years to put out $2,500 down on a new car? And explain. So let me give you a few minutes to try to figure it out, this one first, okay? Okay, so how much, would she have enough money to pay for that car? Would she have enough money in 4 years to put a $2,500 down payment on a new car? No, right? She's not going to have, but only how much is less money. How much would she have after 4 years? 1,600, 760 is right, yes. So all you need to do is just put the amount. This is going to be, it's the PERT because it's continuously. It's a continuously. So it is for the first one. And the second one is just to compare. So it's $1,500 e to the rate, which is 0.04 times 4 years. That gives you the, she will only have $1,760. Right? So no, she will not have enough money. She will have 1,760 with 27 cents. That would be the amount. So no, she will not have enough money for the down payment. Now let's go ahead and do number 9.